Hello everyone, welcome to my math class. In this video we are going to focus on the second group of formulas, which is about trigonometric functions. Let's get started. Differentiation, we will have sine x. Its derivative is cosine x. And for cosine x, the derivative is negative sine x. For tangent x, the derivative is sec squared x. We are going to introduce a memory tape for derivatives of trigonometric functions using a hexagon. Now we have already obtained a hexagon, and we are going to sketch a small circle in the center and write down number 1 inside of the small circle. After that, we are going to connect each vertex with a small circle and join the opposite vertex with the diagonal passing through the small circle. Similarly, we can sketch the other two diagonals by connecting opposite vertices. Then we are going to divide this hexagon into two parts. Then we are going to place these three functions on the left side of this hexagon. Sine x on the top, tangent x in the middle, and at the bottom we will have sec x. On the right part, we will have cosine x on the top, cot x in the middle, and cosec x at the bottom. For the derivatives, we are going to divide them into two steps. The first step, we will determine the sign of them, and then we are going to determine the name of the result. So on the left-hand side of this hexagon, all these three functions, the derivative will be positive. Therefore, we are going to place positive sign. On the right-hand side, we will have cosine, cot, and cosec. Their derivatives will have negative sign. Then for the second step, when we determine the name, we are going to divide these 6 functions in 3 groups. Sine and cosine will be the first group. Then tangent and sec will be second group. Cot and cosec will be in the third group. Then the rule is like this. For sine x in the first group, the derivative is positive cosine x. And then for cosine x, derivative will be negative sine x. Then for the second group, tangent x and sec x, their derivative will be related to each other. For tangent x, the derivative is positive sec squared x. We use the bottom function sec, and here we have squared it. Then for sec x, the derivative will be sec x itself times tangent x in the same group. Similarly, for the third group, for cot x, the derivative will be negative cosec squared x. And for cosec x, the derivative will be negative itself times the other one in the group, which is cot x. According to our syllabus, we mainly focus on these 3 functions' derivatives. Now let's move back to the second group of differentiation and integration formulas. Since integration is the inverse operation of integration, then we can use the differentiation formulas to get the integration result. When we integrate cosine x, it is sine x at c for the indefinite integral. For sine x, it will have negative sign. Therefore, we will have negative cosine x plus c. For sec squared x, when we integrate this function, we will have tangent x and plus c. We can generalize these formulas. For sine x, we are going to generalize x to the linear function ax plus b. Then it is a linear function and the trigonometric function combined together. Then for this, we are going to use the chain rule to get the result. it will be cosine ax, and then the inner function, when we differentiate this, we will have a, and we are going to time a to the front. Therefore, for the corresponding integration formula, we will have cosine ax plus b. Then the integration will be sine ax plus b. Then don't forget to divide this result by the coefficient a. Then we still add c for the indefinite integral. Similarly, we will have cosine ax plus b. The result will be negative sine ax plus b, and then the inner function ax plus b, we are going to time a, sine ax plus b dx equals negative cosine ax plus b. Then we have to divide the whole thing by the coefficient a, then add the constant c in the end. For tangent x, we will have tangent ax plus b. The derivative will be sec squared and ax plus b. Then we have a multiplied to it. If we have sec ax plus b all squared with respect to x, the result will be tangent ax plus b. Then we are going to divide this one by the coefficient of x, which is a. Finally, add the constant c